Awesome. Now you can see the translations there. And a translation, to translate a point along a vector AB, so that's the new kind of parentheses that stands for vector, add A to the x-coordinate and B to the y-coordinate. So in other words, your xy becomes x plus A, y plus B. So to translate the point P, negative 2, 3, along the vector 7, 4, what do? We take negative 2, 3. We're going to add 7 to the x and add 4 to the y. That becomes the point 5, 7. You can see it move from right here, our original point on your paper, and it moves up here. That's called a translation. It just moves it. Moves it in a direction like a piece on a board. Okay? So right here, we have the example triangle M and P as vertices, M negative 2, 1, N negative 1, 4, and P 1, 2. What are the coordinates of the vertices of the image after the translation along the vector 4, negative? All right. So, image after translation along the vector 4, negative 9. So here's what we're going to do here, guys. I'm going to take each of these points, M, negative 2, 1, N, negative 1, 4, and P, 1, 2. Okay? And before we go anywhere, let's see. 1, 2, 3, 4, 5, 10. 5, got to label them 5s, right? 10. Negative 5, negative 10. Negative 5, negative 10. Okay. So, I just want to label these points real quick. So we have negative 2, 1. So negative 2, 1. All right. And we have negative 1, 4. And P is 1, 2. Okay, and let's see this. So negative 2, 1 is, that's M. And again, negative 2, 1. We have right here N, right? Negative 1, 4. N, which is our negative 1, 4. And then over here we have P, which is 1, 2. Perfect. Okay, and if you look at it, that's that nice little triangle shape, right? Okay. And what does it tell me we're going to do? We're going to do it along a vector of 4, negative 9. So that means plus 4, minus 9, plus 4, minus 9, plus 4. You can't really see all that, can you? Minus 9. And we come down to M prime, which is going to be 2, negative 8. N prime, which is 3, negative 5. And P prime, which is going to be 5, negative 7. Perfect. So let's check that out. So we're going to go to 2, negative 8. So that's 1, 2. And then down 5, 6, 7, 8. Boom. That's M prime, right? And then N prime is going to be 3, negative 5. That's 1, 2, 3. And then down to negative 5. That's N prime. And then down over here, we're going to have P prime, which is 5, negative 7. So 5, and then down negative 5, 2, 1, negative 7. And look at that. And here's what I'm going to do, just to kind of demonstrate what's going on here. Use a highlighter to help me. So you can see all these lines have moved to the same angle. Right? P to P, or M to M prime. N to N prime. And P to P prime. Notice how all three of those highlighted lines are at the same angle. It's because we just moved it down and to the right, okay? And it maintained the shape and the angle of each, or the distance and the angle, right? Okay, so that's a translation, and that's an easy way to do it. The vector is real nice. Just write it underneath each one, do the addition or subtraction, come up with your new image, right, which is your prime point. Awesome. So we got one last thing to look at right here. And here, I gotta get it out for you. I'm rocking between papers I've done before and I'm doing live. And I want to talk to you about rotations. So first of all, right here, and hopefully you'll write it better than I did, it says assume rotations are counterclockwise about the origin. So maybe write it a little left here, but assume rotations are counterclockwise about the origin. And then what are we going to do? For a 90-degree rotation, we're going to multiply the y-coordinate by -1, then interchange the x and y coordinates. So in other words, your xy is going to go to -yx. Go ahead and write that down. In fact, why don't you just write down all three of these. I'm going to read them through. And then you can pause it and write them down. So for a 180-degree turn, it tells us to multiply the x and y coordinates by -1. So xy becomes -x, -y. And then for a, well, this should say 270 degrees. Look at that. I had forgot it. For 270 degrees, multiply the x coordinate by -1, then interchange the x and y coordinates. So xy goes to y -x. Kind of the opposite of this one, right? Where that's -yx, this is y -x. Okay? And then what do I mean by that? Well, first of all, take a minute, pause, write this down. Ready, set, go. Okay, good. Hopefully you paused and did that. I'm going to unfold this because I really want you to see what's happening here. Okay, I want you to kind of see these right here. Flatten them out a little bit for you. So for this first one, for the 90-degree rotation, notice what happened. We started out with the point 1, 2. And what does it tell us to do? It says to multiply the y by negative. So the y is, if my x is 1 and my y is 2, then I'm going to multiply the y by -1. So times -1 is going to equal -2. And then I'm going to interchange the x and the y. So my new point is going to be -2, 1, which we see over here. And what's happened by doing that, if you take this angle right here between the 2 points from the origin, then that is a 90-degree angle, that point -2, 1. Over here, to be able to make a 180-degree, a straight line rotation, right? That 180-degree rotation, we just simply multiply both. So if my x is 1 and my y is 2, we're going to multiply both by -1. And we get the new point of -1, -2, which is what you see right down here. It's that p -1, -2. Okay? And that makes a 180-degree rotation. Now we're going to talk about a 270-degree rotation. Right here, this time it tells us to just multiply the x by -1 and interchange the x and the y. So again, if my x equals 1 and my y equals 2, we're going to multiply that 1 times -1, which equals -1. And our new point is going to be 2, -1, which we see right here. Correct? It's that point P prime of 2, -1. Boom. And that makes a 270-degree rotation about the origin. So that is how we do a rotation. Awesome. Okay? So we are going to take a look at this question right down here. The way I'm doing today's lesson, I know it feels a little strange because I got to fold all sorts of papers for just the sake of getting you the information, right? What does it say? It says triangle PQR has points P1, Q45, and R51. Determine the coordinates of the vertices image after 90-degree rotation. So what does 90-degree rotation tell us to do? It says that if you look up here, 90-degree rotation, XY goes to -YX. So let's write that down. XY goes to -YX. So here's all I'm going to do. My new P prime point the negative 1, 1. That's negative yx. My new q prime point is going to be, let's see, negative yx, so negative 5, 4. See how I just made the y value negative and interchanged the values? And my new r prime, it's really this easy, is going to be negative 1, positive 5. Boom. That's it. That's how you do a rotation. You just follow the formula. You understand the assignment, right? Okay, with that said, let's go tackle the world, or at least the world of transformations. Peace out.